Hi, my name is Ricardo Ruiz, and this is the mini challenge number 2. So basically, here's a breakdown of my code. Firstly, I established every variable that we will use. It was already provided by the presentation. So we will use a world, a base link, the chassis, the right wheel, left wheel, the caster, and the markers for the figures. So we declare those each one of them. So we declare as transform stamped for the links, and we declare marker for the figures. Then I chose to use the code based from the ABB robot. So it is made out of functions. So firstly, we have the initialize the frame, but I couldn't do it as if the main master was world and the slave was base link. So I had to create another one which was named with the exact same name. So it is a world and world. So well, and obviously like don't change the positions and stay the same. But what I had to do for it to work properly, because if I didn't, the base link didn't rotate. So well, that's the first thing I did. So then I declared the base link, but inside the function, it's just the which one is the master and which one is the slave, because in the while loop I put it the equation of the quantum quaternation, and well there overlaps the configuration of the defined depth because it's inside the while loop. Then I declare the right wheel, which will be linked to the chassis. So we now have the world, which is linked to itself in world in the zero position. The base link, which is linked with world at the exact same position, just moving in the x-axis. Then I have the right wheel, which is linked to the chassis, that it's moved only in the y-plane, and the exact same for the left wheel, but instead of positive movement or distance, negative. And then I have the caster, which is a little bit lower and in the back. So I move it in the minus x-axis and minus z-axis. And then I have the markers, the functions for each marker. So here basically just the name of the linked in which is it will appear in the RVs, and the positions, the initial positions and the orientation of the figures. So here in the chassis I linked it with the base link transform rotation, which well it will follow the trajectory, and you just declare the color, and that's it. And that process will change with the wheels, since I had to use quaternation because the cylinder appeared to be like standing up, so I had to make it as if it was sideways. So with quaternation, in which I just moved the first value to minus mp dot pi divided by 2, and inside the orientation I added the w, and I just equal those values to the matrix, the four matrix values. So I repeated that same procedure for the left wheel with the quaternation values, and finally, for the caster, just found the right scale, and well, obviously in each one of them change the type, because with the type you change the type of figure that you're placing. So I have 1 for rectangle, 3 for the cylinder, and 2 for the sphere. And well, that's it for that part, for the functions. And now for calling them out. So here inside the if loop, the main one, I put it at the publisher of the markers with the queue size and well, just the name in which it will appear, the loop rate at which it will update itself, and well, the name of every single function that I established in earlier. So I have all of those, and then just establish if it's an static broadcaster or a transform broadcaster, static transform broadcaster, or just transform broadcaster. In my case, I didn't choose to move the wheels, so I will just have the base link as a transfer broadcaster and everything else and as an static. And finally, in the while loop, I just start the time now, the Rossby time now, and here is I put the configuration for the base link, because if I put it outside, it wouldn't turn. So here in the while loop, I put it a quaternion with the last value of t over 2, and that will be the rate at which it will move. And in the translation, it's just 2 times pi, 2 times sine of the speed, the t above 2. And and the same for the y, 2 times cosine of t over 2, which, well, it's the time also. And well, just in the rotation, the matrices from the quaternion. And that's basically it. The final thing is just to put the send transform and publish the markers. And that's my code. So here's a quick look of the code. As I mentioned earlier, here's are just establishing the variables, then the functions for the initial positions, and well, here we have the what I was saying earlier, that I had to put the same one linked to its own. And well, here it doesn't appear this because, well, I put it in the while loop. And here are the markers for each one. This was the chassis one, and here are the wheels that I had to put the quaternion with its matrix. And here is the main loop, which only publishes the markers and sends itself to the functions. And here are the publishers and the broadcasters. So as you can see, the only one which is going to be dynamic is the base link. And here in the while loop, this is all from the base link. And well, here's the rate at which it will be moving, and that's it. The send transform and the publish. And to look at it work, we're gonna go here. I also created a launch file which only calls out the RVs and the node, the package, and my Python file. So, well, basically here just develop and launch. Establish the world, add the TF, here it is, and I add the markers. And now I have my full card.